So we're now going to talk about the second part of the case study. This part's going to explore some other methods. In particular, it's going to focus on the do-on-error method and the map-not-null method. These are two operators that are interesting and a little different from what we've talked about before. And this time, we're going to use these to create, divide, and display big fraction objects synchronously. Once again, not the normal use case to do it synchronously, but we haven't talked about concurrency yet, so that'll come shortly. And as always, you can get this in my GitHub repository in the ex1 project in the reactive Flux folder in the live lessons repo. So here we are in the ex1 project in my GitHub repository. And we're going to go ahead and take a look at the ex1 driver program. We're going to focus now on test fraction, division error sync, and test map not null. So we're now in the test fraction division error sync method, and you can see what this is going to do is it's going to demonstrate how to do erroneous division using a synchronous Flux stream. So let's take a quick look at this. We make a new string builder to keep track of the diagnostics we're going to log. We then make a list of big fraction objects, and you'll notice that they have a little different values than before, and you'll see why in a second. And then we're going to go ahead and turn that big fraction list into an iterable. And then we're going to do some funky stuff here in order to be able to have both erroneous and correct results being emitted in this Flux stream. So what we're going to do is we're going to define a map transforming operation, which is going to check to see whether or not the big fraction that's being emitted here, one of these guys, is equal to 2. And you can see here that this third one here is equal to 2. 100 over 50 is, of course, 2 when it's reduced. And if it's equal to 2, we're going to try to divide by 0. Otherwise, we're going to divide by 2, just to give both erroneous and correct results. And then what's going to happen here, you can see, is if we succeed, if we don't divide by 0, we're going to print the results or put them into the string buffer. We're going to log them. But if we do end up getting a divide by 0, do-on-next is going to be skipped, and the do-on-error method is going to be called. And the do-on-error operator is going to go ahead and log the exception. So what's going to happen here is if we don't have an error, do-on-next will be called. If an exception or an error is raised, then do-on-next will be skipped, and do-on-error will be called. So depending on what happens, one of these two things will be skipped. And then we go ahead, as we've done before, we subscribe, we print the results out. And what you'll see is that when we run this in a second, you'll see that the results are going to show how we get the first two values logged, and then the next one will be an error, and we'll log that. And then the whole program will bail out at that point because we got an exception that wasn't handled. Now, we'll talk later in the course about how to handle exceptions. This example does not handle exceptions very cleanly. It just logs the fact that they have occurred. And when we're done, we return this s void m thing just so that we can clean up and tell the underlying async task barrier framework that we're done. Remember, the task barrier framework works by taking a void, a mono to void, and mono to void is then used by the then operator in the implementation here in order to know to return. The next method we're going to take a look at is test map not null, which is going to create a Flux with a bunch of big fractions in it. And in this case, we're going to do something like we did before, except rather than throw an exception, what we're going to do is we're going to log each of the results, and then we're going to check to see if the big fraction is equal to 10. And of course, it will be equal here, because that's 10. And if it's equal to 10, we're going to emit a null. Otherwise, we're going to emit the big fraction. And so what's going to happen is, because we're using map not null here as opposed to map, when a null is emitted, it's just going to be ignored. So when we look at the output here in a second, you'll see that it's just going to skip over the nulls. And as usual, we go ahead and we subscribe, and it'll print the results out after it logs them. So let's go ahead and run this example, and you'll see all the results come out, not just the ones that are related to the last two examples. We also see the ones we did earlier. And so if you look at that, you can see test multiplication sync 1 prints some results. The test fraction multiplication sync 2 prints some results. Test fraction multiplication 3 prints results. And then we see the ones we just looked at, and you can see here that we are going to have the do-on-next call handle the first two emissions, and then when the error occurs, it's going to say, I tried to divide by 0, and at that point, we bail out. And then you can also see that the test map not null skips over the null. Just for kicks, let's go back over here, and let's change this from map not null to map. And we'll rerun the program and see what's going to happen in that case. And you can see what happened. It does not like, the fluxes do not like nulls in their flux streams. So in that case, we get an error, get an exception. So the right way to handle this, if you have potential for emitting nulls, is to use map not null, and then everything is happy.